Question 14. The curves y equals x minus 1 in brackets squared and y equals 5 minus x squared intersect at 2 points as shown in the diagram. Part A. Find the x coordinates of the points of intersection of the two curves. Find the x coordinates of the points of intersection by solving simultaneously the equations y equals x minus 1 in brackets squared and y equals 5 minus x squared. Now, because the left-hand side of both equations is the same variable, the variable y, we can equate the right-hand side of both equations, effectively using the substitution method of solving simultaneous equations. So x minus 1 in brackets squared is equal to 5 minus x squared. Expanding the left-hand side, we get x squared minus 2x plus 1 is equal to 5 minus x squared. Moving the terms on the right-hand side over to the left-hand side and collecting like terms, we get 2x squared minus 2x minus 4 equals 0. Now this is a non-monic quadratic equation, but it also happens that the coefficients of x squared, x, and the constant term are even numbers. So we can divide all terms by 2 and we get x squared minus x minus 2 is equal to 0. This is a monic quadratic equation, which is certainly easier to solve. In fact, by inspection, we can factorize the left-hand side. We get x plus 1 in brackets times x minus 2 in brackets is equal to 0. That is, we need to find two numbers whose sum is negative 1 and whose product is negative 2. So positive 1 and negative 2 will work in this case. So from the left-hand side, from these two factors, we have the x coordinates of the points of intersection are x equals negative 1 and x equals 2. Part B. Find the area enclosed by the two curves. The area between the two curves is the difference in the area between the concave-down parabola and the concave-up parabola between the 2 points of intersection that we've found in part A. So that's from x equals negative 1 to x equals 2. So to find the area, we integrate both curves. And notice that we start off with the concave-down parabola because between x equals negative 1 and x equals 2, the concave-down parabola is above the concave-up parabola. So the area A is given by the integral from x equals negative 1 to x equals 2 of 5 minus x squared minus x minus 1 in brackets squared dx. Expanding this bracket here using perfect square expansion, we get the area is equal to the integral from x equals negative 1 to x equals 2 of 5 minus x squared minus open bracket x squared minus 2x plus 1 close bracket dx. It's important to keep the expansion in brackets for now. In the next step, I'm going to expand this bracket here. So this negative will be multiplying all terms inside this bracket there. So expanding the brackets, we get the area is equal to the integral from x equals negative 1 to x equals 2 of 5 minus x squared plus 2x minus 1 dx. Collecting the like terms, the integrand becomes 4 plus 2x minus 2x squared. Notice that all three terms of the integrand are divisible by 2. So factorizing out 2, placing it outside of the integral, which will make the integration a little easier, we get the area is given by 2 times the integral from x equals negative 1 to x equals 2 of 2 plus x minus x squared dx. So integrating this expression here and noting this 2 that's multiplying the integral, we get 2 times 2x plus x squared over 2 minus x cubed over 3 from x equals negative 1 to x equals 2. So applying the limits of integration, we get 2 times, I'm going to open square bracket here and open round bracket, 2 times 2 plus 2 squared over 2 minus 2 cubed over 3, close round bracket, minus open round bracket, 2 times negative 1 plus negative 1 in brackets squared over 2, minus negative 1 in brackets cubed over 3, and we're closing the brackets here. So evaluating what's inside the round brackets, we get 2 times 10 over 3 minus negative 7 over 6. and that evaluates to 9. Therefore, the area is 9 square units.